Abhiyanta Siksha is launched with a motto to impart an experiential understanding of technical education. The course outcomes are: equips junior engineers to solve real-time industry problems, prepares graduates for competitive exams, supports engineering students in their graduation studies, benefits diploma and high school students in engineering sciences. Problems are explained, solved, and supplemented with hands-on practice for students. Welcome to the online course Abhiyanta Siksha. The topic that we are covering in this course is engineering mechanics with subtopic friction. Let's understand D'Alembert's principle for a dynamic condition. The system of forces acting on a body in motion is in dynamic equilibrium with the inertia force of the body. Let R be the resultant of all forces, then according to the Newton's second law of motion, R is equal to ma, where m is the mass of the body, a is the acceleration. According to D'Alembert's principle, R minus ma equal to 0, where ma is the force of magnitude applied in opposite direction of motion and is termed as inertia force or reverse effective force. In general, when a body is in under translation for a rectilinear motion, the D'Alembert's equations are sigma fx equal to ma x and sigma fy equal to ma y, or otherwise you can express as sigma fx minus ma x equal to 0 or sigma fy minus ma y equal to 0, and these are said to be dynamic equilibrium conditions. For a curvilinear motions, sigma fn minus man, that is normal acceleration, equal to 0, where normal acceleration is given as v square by r, and sigma ft minus mat equal to 0, which is at tangential acceleration, is given by dv by dt. So it is preferred to use D'Alembert's principle, since just by applying a reverse effective force, the moving body can be treated as a body in equilibrium and analyzed by using equations of static equilibrium. Now let's solve some problems in friction which are subjected to motion and under dynamic condition. The problems connected to dynamic condition are based on D'Alembert's principle. So D'Alembert's principle basically talks about the dynamic equilibrium condition, in which the equilibrium condition is stated as sigma fx minus max equal to 0. This is the net forces in x direction, where sigma fx is the external force sum and max is the inertia force, and sigma fy minus may equal to 0 and sigma m minus I alpha equal to 0. Now coming to the problem, we have two weights 200 Newton and 800 Newton connected with a thread. These two blocks or weights pulled by an external force 400 Newton in the right direction. Now the surface friction, which is mu is equal to 0.3 for both the blocks. Now the question is, calculate the tension in the thread and the acceleration of the system. Now let us start step by step. First, consider the free body diagram of 200 newtons. Now since the body is already in the motion and the motion is in the direction of external force, that is in rightward direction, the inertia force and the frictional force acts in opposite direction. So considering the free body diagram, that is, you have this 200 Newton here and a normal reaction on the same line of action. Then you have tension, because this is a tension, you have the tension here in the thread, and there is a frictional resistance let me call this N1, so F1. Now, since the body is moving in the right direction, there is an inertia force which is given as W by G, or I can say W1 by G into AX. I am showing A suffix x is acceleration in x direction. If you assume that this is x direction and this is y direction, in this system the body is moving only in x direction. There is no motion in y direction. So, that is the reason we have to specifically mention A suffix x, that is mass into acceleration, which is the inertia force. Now, these are the forces that are acting on the body. Now, in this forces, apply this dynamic equilibrium condition, that is sigma Fx minus Max equal to 0. That is the sum of the forces in x direction. Those include this as well as this. That is, you can say plus T minus F1 minus W1 by G into Ax equal to 0. Here F1 is equal to mu into N1. Now, how do you get N1? Since there is no motion in y direction, you just have to simply apply the equilibrium condition sigma Fy equal to 0 and N1 is equal to 200 newtons. So, these are the set of equations for the free body diagram of 200 newtons. Now, let us write down the equations for 800 newton. The 800 newton body has the forces. One is the weight, the other one is the reaction N2. This is the tension T, because this T and this T creates tension in the thread, and there is an external force 400. Since the motion is in this direction, there is a frictional resistance F2 here and inertia force, let me say W2 by G into Ax. Now, write down the equilibrium conditions. Sigma Fx minus Max equal to 0. Here the net forces here are 400 positive minus F2 minus T minus W2 by G into Ax equal to 0. So, let me call it as equation 2, where F2 is equal to mu into N2. And again here, since there is no motion in y direction, you have to just apply sigma Fy equal to 0, where N2 is equal to 800 newtons. So, you apply equation from equation 1 and 2, you can calculate the tension and the acceleration. So, 2 unknowns and 2 simultaneous equations. So, tension is around, if you calculate, comes around 80 newtons, acceleration is 0.981 meter per second square. So, this is how you apply D'Alembert's principle to the system. Now, let us go to the next problem, problem number 6 in dynamic conditions. Now, there is a system of bodies, one is 1200 newtons connected to another 800 newton body with a rope. So, the body is now moving up on the inclined surface which is at an angle of inclination 12 degrees. The question is, what is the tension in the string, the acceleration with which the body is moving up. The second thing is, when this body is started from rest, after the motion 3 seconds later, what is the distance covered by this body is the question. The coefficient of friction on these two is given as 0.2. Now, again we need to apply D'Alembert's principle step by step. So, let us first take this the inclined surface body. Now, in the inclined surface body, this is 12 degree, right. Now, this is the weight, that is 1200 Newton, which is again perpendicular to the ground surface, and then you have normal reaction N perpendicular to the inclined surface. There is a tension in the string by this, okay. Then the body is in motion in upward direction. So, there is a frictional resistance F and inertia force, that is 1200 by G into AX. I consider this as X there, because Y there is no motion, there is only motion in X direction. Now, let us resolve all the forces in this plane. So, this is 1200, 12 degrees. So, this becomes 1200 cos 12, this becomes 1200 sin 12, this is F, and further this is T, this is N. Okay. So, we have considered all the forces, right, force F and T in the other direction. Then you have one more inertia force, that is 1200 by G into AX. So, writing down the D'Alembert's principle, sigma Fx minus MAX equal to 0. See, what is the net force? This minus 1200 by G into AX minus 1200 sin 12 degrees minus F plus T equal to 0. This is equation number 1. Then, what is F? F is equal to mu into N. Now, you need to determine what is N. For that, since there is no motion in Y direction, you just have to take sigma Fy equal to 0, where N is equal to 1200 cos 12 degrees. Substitute this value of N into the equation and get the, you have still two unknowns, one is A, other one is T. So, you need one more equation to solve the equation. The next thing is, go to the body number 2, 800 newtons. So, this 800 Newton has a weight acting downwards and there is a tension in the string. Since the weight is not in contact with any surface, frictional resistance does not act on the body. However, the body moves in downwards, so the motion is in downward direction. Since the motion is in downward direction, your inertia force, that is 800 by G into AY, is in upward direction. Now, this Y direction there is a motion, there is no motion in X direction. So, these are the forces that are acting on the body. Now, the D'Alembert's principle, sigma Fy minus MAY equal to 0, that is T minus 800 minus 800 by G into AY equal to 0. Since the acceleration is same, you can consider Ax equal to Ay, and considering this as equation number 2, solve these two simultaneous equations 1 and 2 and derive the tension and acceleration. So, if you solve these two, two unknowns and two equations, you get tension around 673 newtons and acceleration around 1.98 meter per second square. So, okay, the first two unknowns are calculated. The next question is, what is the distance covered by this 800 Newton which is started from the rest after 3 seconds? So, apply the equation of motion to the body as S is equal to ut plus half at square, given u as 0 and t as 3 seconds, and acceleration which is obtained as 1.981 meter per second square. You substitute that and solve the value of the distance travelled. This, it is coming around 6.7 meters or so. The distance travelled by 800 Newton is 6.7 meters. Now, let us solve problem number 7. The problem number 7 is, the bicycle is rolling on an inclined surface which has an inclination of theta. Theta is the slope of the surface. Now, 2a is the distance between the centers of the front wheel and the rear wheel. The weight of the bicycle lies at a point G, which is at a height of h from the inclined surface. X is from the middle point, which calculates to be a minus x and a plus x. Now, the question is, what is the greatest slope theta for the bicycle to rest without slipping? If one condition is the rear wheel is braked, the second condition the front wheel is braked. So, let us start first with when the rear wheel is braked. Okay. So, let me draw the free body diagram. You have the front wheel here with its center, the rear wheel with its center here, right. Then we have the weight acting at a height of g, right. So, the weight always acts perpendicular to the ground surface, right. Now, this is the front wheel, this is the rear wheel. The reaction, normal reaction, is always perpendicular to the surface, inclined surface. I call it as NF, and the normal reaction on the rear wheel, call it as NR, right. Now, the wheels are rolling in this direction. The first condition is the rear wheel is braked. Now, when the bicycle is rolling down, the motion in this direction, the wheels rotate in anti-clockwise direction. Therefore, while rolling, the friction actually lies downwards. But here, the condition is rear wheel is braked. That means a brake is applied at the rear wheel. Then the friction will act in opposite direction to the motion, right. Now, this is what is called frictional force when the rear wheel is braked. That means, when the brake is applied to the rear wheel, the frictional force acts in the upward direction. Now, once you know this, let us resolve all the forces on this x dash, y dash, y dash. on x dash and y dash this thing. Now, if I resolve this way, then what happens? This is theta, right? Then I can resolve this as w cos theta and w sin theta. Now, let us put all the forces in xx dash and yy dash direction. X dash, y dash direction. Then you have on the top w cos theta, right? Now, towards left is w sin theta, then towards right is frictional force, then you have, I can say, n r and n f upwards. So, these are the forces that are acting on the system, okay, both inclined surface and the wheels. Now, you write the equilibrium conditions for this. First is sigma fy dash equal to 0. We have w cos theta equal to nr plus nf, that is equation number 1. Then sigma fx dash equal to 0, we have w sin theta equal to fr, which is equal to mu into nr. Let me call it as equation number 2. Now, for us the unknowns here are theta is one unknown, and what do you have? W is also an unknown, weight of the vehicle is not given to you, and we have even nr, nf are also unknowns. So, more number of unknowns are more than the equations. So, let us write one more equilibrium equation. Let me call this point as B and this point as A. So, I will take moment of the forces about B, right. So, let me call sigma mb equal to 0. Sigma mb equal to 0. Let us look at the forces that contribute to the moments. One is w sin theta, the other one is w cos theta, the one more is nf. Now, we know these distances, this as a plus x, this as a minus x, and the whole of it as 2a, right. Now, let me take first nf. The moment caused by nf about the point B. See, nf is in the upward direction. It is rotating about B in this direction, which is clockwise. We already have the convention, clockwise is positive, counterclockwise is negative if you take. So, this clockwise force is nf, distance is 2a. So, let me say plus nf into 2a is one moment. Then w cos theta, which is in downward direction, if it takes moment about B in this direction, it goes in this direction. So, with a distance, perpendicular distance a plus x, that means w into cos theta into a plus x. Then one more force, that is w sin theta. W sin theta, the perpendicular distance about this point is h, and this has to take moment about this point in this direction. That means it rotates in this direction, anti-clockwise direction about B. Okay. So, about B, I can say minus w sin theta into h equal to 0, equation number 3. So, you have three simultaneous equations wherein you can calculate the unknowns nr, nf and w, and then finally get your tan theta value. So the slope can be obtained from here as tan theta equal to mu into a minus x by 2a plus h nu. So this is the value of the slope required for the bicycle to rest on the inclined surface when the rear wheel is braked. Means a brake is applied on the rear wheel. So the next question is, when the front wheel is braked. When the front wheel is braked, the same procedure, but apply the frictional force on the front wheel. That goes this way. I shall draw the free body diagram. Okay, this is the front wheel, this is the rear wheel. Okay, let me call this as W. Again, this is theta, so this becomes W cos theta, this becomes W sin theta, this is NF, this is NR, NR. The only difference is this time the vehicle, we are considering the front wheel motion, and the friction on the front wheel once the brake is applied is in the upward direction, FF. Now do the same exercise of resolving the forces and write down the equations of equilibrium sigma Fy dash equal to 0, which comes to be again W cos theta equal to NR plus NF, that is equation 1. Fx dash equal to 0 is again W sin theta equal to Ff, that is mu into Nf, equation number 2. Now this time the moment we take it at front wheel contact point, that is sigma Ma equal to 0. Now in sigma Ma equal to 0, you have the equation about moment about this happens to be, this is h, we know that, and this is 2a, and this is a minus x, and this is a plus x. Okay, now we have NR again in counterclockwise direction minus NR into 2a, then W cos theta goes this way, that is clockwise direction, plus W cos theta into a minus x, W sin theta into h again minus W sin theta into h, okay, equal to 0 is equation number 3. Now you get tan theta as mu into a plus x divided by 2a minus h nu. This is the slope that is required for the vehicle to rest on the inclined surface when the front wheel is braked. So this is how you calculate the frictional forces and the required greatest slope. Now let's look at problem number 8. A 750 Newton crate rests on a 500 Newton cart. So this is a 750 Newton crate resting on 500 Newton cart. The coefficient of friction between the crate and the cart is 0.3. So at this contact surface the friction is 0.3. And the coefficient of friction between the cart and the road, that means near the wheel contact surface, the coefficient of friction is 0.2. If the cart is to be pulled by a force P such that the crate does not slip, then determine the maximum allowable magnitude of P and the corresponding acceleration of the cart. So here we need to solve this particular problem by using two free body diagrams. One is for the 750 Newton crate with the frictional force and weight, and the next free body diagram is on 500 Newton cart with external force P and frictional force acting at the contact surface of the wheel and the road surface. So this solution is available in the notes provided in the description link. Now let's look at problem number 9. Two blocks A and B are released from rest on a 30-degree inclined plane when they are 18 meters apart. So this is A, this is B, placed on an inclined plane at an angle of 30 degrees. And these two blocks are at a distance of 18 meters, and now they are released from rest. The coefficient of friction under the upper block A is 0.2 and under the lower block B is 0.4. That means it is indicating that the materials of block A and block B are different. In what time block A reaches the block B? What will be the contact force between them? The weights of block A and B are A is 100 Newton and B is 80 Newton respectively. So this problem solution is also available in the notes provided in the description link.